In order to determine a square root, we have to make a list of squares to begin with. So 1 squared means 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9. So I made a list like that going all the way down. What you want to do is you want to look at the number underneath the radical, 4 in this case. Look for that on your list. It's right here. The number in front of the exponent is your answer. So the answer is 2 for that one. This one has a 9, so you look at 9 on the list. The number in front of the exponent, the 3, is your answer. The negative in front of this next one just stays in your answer. So we're looking for 49. 7. So negative 7 is the answer on that one. Any signs out front just stay out front. So this is going to be a negative here. 25 has a 5 in front of the exponent, so negative 5, because the negative was already there to begin with. Okay, with decimals, what you have to do with decimals is, first of all, this plus or minus on the outside stays in your answer. You look for the number without the decimals. So we're looking for the number 1. So it is a 1. So 1 has a 1 in front of the exponent, so the answer is 1. But because there's a decimal involved, you take your decimal divided by 2. So you have 2 decimal places. 2 divided by 2 equals 1. You always divide by 2. That means there's one number after the decimal in your answer. In other words, the one that we got is going to have a decimal point in front of it. So again, you count the number of numbers that are after your decimal point and divide by 2. That tells you how many numbers are after your decimal point in your answer. Okay, so for number 6, we have a negative. 64 has an 8 in front of the squared, so that's an 8. We've got 2 numbers after the decimal. 2 divided by 2 is 1. So I need just one number after my decimal point. This next one, you have to split them apart as the square root of 9 over the square root of 16, and then handle the top and bottom separately. So the square root of 9 is 3, and the square root of 16 is 4. So 3 over 4 is the answer to that one. Okay, this one is special. The negative's not on the outside, it's on the inside. The square root of negative 1 over the square root of 25. Okay, here's the rule. If you have a negative underneath, the answer is not real. So you automatically have an answer that's not real. So that's your answer. You don't have to do the rest of the problem because a negative underneath a square root is automatically not real. Okay, solving the equations goes the same way. You always solve equations by doing opposites. The opposite of square is square root. So what we're going to do is we're going to take the square root of both sides, like this. Opposites cancel. So a square and a square root cancel. And the square root of 121, I didn't go enough on this list. 11 squared is 121. So the square root of 121 is 11. On this one, the square root of a squared equals the square root of 3600. Okay, opposites cancel. So a equals, okay, 3600 is not on our list. We can extend the list to make it be on the list, but it's much easier to think of this as 36 times 100. Because the square root of 36 is 6, and the square root of 100 is 10, and 6 times 10 is 60. So sometimes it's better or easier to break it down into perfect squares, products of perfect squares. Okay, this one, the square root of p squared equals the square root of 81 over the square root of 100. Opposites cancel. So P equals the square root of 81 is 9. The square root of 100 is 10. So 9 over 10 is the answer to that one. This one, the square root of t squared equals the square root of 121 over the square root of 196. Opposites cancel. T equals square root of 121 we said earlier was 11. 196. I didn't do 196. 12 squared equals 144. 13 squared. 13 times 13 is 169. 14 times 14 is 196. So that's a 14. 11 over 14 is the answer to number 12.